Alright guys, so what I'd like to take a look at today is something called the fundamental theorem of algebra. I just love that little video clip. I don't know if you guys have seen the movie, but he just makes a perfect logical argument and explains it wonderfully, and he wins the argument, which is great. So I thought I'd start out off with that. We have been talking about synthetic division, polynomial long division, finding zeros, so on and so forth. Well, today we're going to kind of sum it all up and show you guys where it all kind of really begins, and what on and so forth. To start off with, we do have a little daily question here, and it says to find all the possible roots of the following polynomial function. Alright, so this is where we're finding our p and our q. P is always, again, the factors of your last term. So in this case we have 8, so it's 1, 2, 4, and 8. And for q it's 1 and 2. So to find all of my possible roots, it's just your p's over q's. So like we talked about in class, I'm going to do 1 over 1, which is 1. 1 over 2, which is 1/2. I'm going to go down the line. 2 over 1 is 2. 2 over 2 is 1. Good. 4 over 1 is 4. 4 over 2 is 2. 8 over 1 is 8. And then 8 over 2 is 4. So if we look at what our possible roots are here, we have plus or minus 1, 1/2, 2, 4, and 8. Okay, and then those were what we could use to start with. Okay, very nice. Pardon me. The fundamental theorem of algebra. Okay, so here, drum roll please. If f of x is a polynomial function of degree n, and n is greater than 0, then the function will contain exactly n roots. This is true as long as we take into account that some roots are counted more than once, possibly a double or triple root, and some roots are imaginary. Okay, so we talked about this in class, setting up this a bunch of different times. Here's just an example. If I have something in terms of, let's see here, 4x to the 5th minus 3x to the 4th plus 2x squared plus 6. The highest possible number of roots we can have is the highest degree, which is 5. 5 possible roots. Okay. Now, what you could have though is a number of double roots and triple roots. Okay, like we talked about in class 2, that add up to 5. So all it's saying is the highest number of answers you can have is the highest degree. The one important thing that I want you guys to make sure you write down here is imaginary roots always come in pairs. Okay? Please jot this down. Imaginary roots always come in pairs. You always have to have a plus or a minus for imaginary roots. Just, it has to be done. Okay? So, now, this is much the same as yesterday we talked about in class. So we're going to take a look at a few of these together. Number 1, determine the number of roots in the following functions, and then find all zeros of the function. So for number 1, I have 4 possible roots. Okay, 4 possible roots. So what I'm going to do here is, I'm going to use my graphing calculator, and I want you guys to do this. You're on your home screen, top right, or sorry, top left is y equals. I'm typing in my function here. X to the 4th plus 5x to the 3rd plus 5x squared minus 5x minus 6. I have it. I'm going to graph it. Okay. Now, you're going to probably be in Zoom Standard, which is right here. This is how your graph would look. One thing I'd love for you guys to get comfortable with is I like to zoom in a little bit so I can see it better. If I hit zoom and then number 4, it zooms it in. Now, this -3, -2, -1, 0. I'm going to jot these down real quick. -4, -3, I'm sorry, not -4. -3, -2, -1, and 1. Alright? So it says determine number of roots in the following. Got it. There's my 4. I think I'm going to have 4 real. Let's just check it out. I'm going to do my synthetic division. Okay? So all of my coefficients out. 1, 5, 5, -5, -6. I can pick any one of these 4 to work with to start with. I'm going to pick the 1 because it looks easy. And here we go, just proving that this is true. Bring the 1 down, I'm just synthetically dividing here. Oops, that's a 1. Okay. Adds up to 6, 6, 11, 11, 6, 6, 0. Good. Now I brought it down from x to the 4th to x to the 3rd. I want to do it one more time. So I already picked 1. Let's pick a different one. Let's go with negative 1. Okay, so 1 gets brought down. Negative 5, 5, 6. Okay, actually I'll do that one again, so we're good. Alright, so let's look what we have here. This written as a binomial would be x minus 1. This written as a binomial would be x plus 1. And then this, since I brought it down twice, goes from x to the 4th to x squared. So 1x squared plus 5x plus 6. Okay, there's my function. F of x equals. Now, I'm going to factor this last and final one. Sorry, I switched them up. I just wrote the plus first. If I factor x squared plus 5x plus 6, I get x plus 3, x plus 2. Now, what you've just done is, if I set each of these equal to 0, okay, I have x equals negative 1, I have x equals positive 1, x equals negative 3, and x equals negative 2. And we just proved it. We have 4 real roots. Okay? I know what you're thinking, Mr. Howe, we just figured it all out from the graph itself. I'd still like you to show this work. It's not that difficult, and it just verifies that you've got the correct answer. Okay? And it won't always be the case, because sometimes we're going to have ones that are imaginary or are not like real numbers. They might be irrational, so on and so forth. Okay? So, very good. And again, we're using the calculator to kickstart us off. Now, for my second one, this is an x squared, by the way, in case you couldn't think that one through. Going back to y equals, I'm going to clear this out. I'm going to type in x to the 3rd minus x squared plus 25x minus 25. And I'm going to hit graph. Okay, so I'm still zoomed in, but it's okay, because here we go. I have a 1 right here. Now, because I'm going to zoom out so you guys can see this. I only hit on the x-axis at one time, but I have 3 as my exponent. Okay? What does that tell me? Well, that tells me I'm going to have 1 real root and then 2 imaginary roots. That's my fundamental theorem of algebra right there. Okay? Since it only hits one time, it's just 1 real. All right, let's see what we can do. So again, I'm going to write out my coefficients. 1, negative 1, 25, negative 25. I know 1's a solution, so I'm going to throw 1 out here. Bring the 1 down, multiply. Okay. If I write that as a binomial, it's x minus 1. This goes from x cubed down to x squared, so 1x squared plus 25. Alright, now you'll notice this is a sum of squares. I cannot factor that. So this is easy. X minus 1 equals 0. I can solve that, no big deal. X equals 1. Here, when I set this equal to 0, check out what happens. I subtract 25 over. I square root left, I square root right. I get plus or minus 5i. So wouldn't you know it, my 1 real solution here is 1. My 2 imaginary is plus or minus 5i. And we've got all of our answers. This is where you guys have to know this process. I cannot find imaginary roots via graph. They don't exist. Okay? Hence they're imaginary. So what you have to do is you have to go ahead and go through the process, solve it this way. Okay? Please don't forget your plus and minus because it shows both of them. Alright, on to the back. Again, this is just more practice with it. Determine the number of roots in the following functions, find all the zeros. Let's see if we can get one more done, and then I'll make a second video for you guys. Here's my graph, or my calculator. I can type in x to the 3rd plus 3x squared minus 2x minus 6. I'm going to hit graph. So here, okay, I'm going to zoom in a little bit. Zoom decimal. It hits at -3. It looks like -1.5, and it looks like +1.5. I'm not totally sure. You can do this and kind of scroll over to double check, but it doesn't give me an exact one, so I can't just go 1.3, 1.4. But I do know this one's -3. That one makes me happy. So this is 3 real, which is 3 real. And I'm going to use the one that makes sense. Okay, here are all my coefficients: 1, 3, -2, -6. Alright, bring the 1 straight down, multiply, multiply, multiply. There we go. So is this written as a binomial as x plus 3? This is x squared plus 0x minus 2. Okay. Now I'm going to go ahead and set each of these equal to 0 again. So x plus 3 equals 0, x squared minus 2 equals 0. Okay, the first one's simple enough. Subtract it over. X equals -3. On the right, if I add 2 over, I get x squared equals 2. Square root left and square root right, x equals plus or minus root 2. And this is why this is an irrational answer. If I looked at my graph again, square root of 2, alright, it's a little bit bigger than 1. Well, there we go. It's like 1.3, 1.4-ish. But I need the exact answer, hence why I had to do this work. Okay? So, I think that's a pretty good place to stop. The second video will have number 4, 5, 6, and 7. And then we'll be all finished up with these notes, and you guys need to get a few practice problems. As always, keep up the good work and good luck. We are all counting on you. See you soon. We're all counting on you.